My name's David Darby. I'm the CEO of Ecospark. And you've heard a lot about green technology so far today, but I'm going to talk about white technology. I'm going to talk about white LEDs. And as you all know, the sun is white, not yellow. So when we think about white light, we should think about white sunlight. So the challenge. Today, 25% of energy is used in lighting. And incandescent light bulbs are being phased out by 2012. They'll be banned inside the EU. But if we look at the alternatives we have today, compact fluorescent lights, they contain mercury, so they're not environmentally friendly. And they have a light quality and a turn-on time that's not very desirable, particularly for home use. And LED lamps, they're starting to come onto the market, but today's LED lamps are still too expensive, and they also have a light quality that is not particularly desirable to have in your home. If we look at the market for lighting is huge. Today, the market for lighting sources, forget lamp fittings and everything that goes with them, just the sources, is $15 billion, of which the LED part is relatively small today. But if we look at this data from Philips over the next 5 years, it's predicted that the lighting market will grow to $25 billion, but more importantly, the LED segment will grow very significantly, have a growth rate of over 60% per annum. So there's a huge market for LED lighting. What is it we do at Ecospark? We make white LED chips. And our aim is to make a lighting source that can replace the filament in an incandescent light bulb, to have an efficiency greater than 100 lumens per watt, so that you could make a 40-watt light bulb using 6 of our LEDs. The technology we use is based on zinc oxide, combined with nanotechnology. We use zinc oxide nanorods in our devices. So we start with a substrate. That can be glass or plastic or semiconductor like silicon. Then we use a polymer layer on top of this, which provides the P-type material, the hole injection. And then we grow our zinc oxide nanostructures on top, and then fill in with an insulator, and finally put metal contacts onto the structure. The advantage is that the cost of production is lower than with today's LED devices. And the other big advantage we have is we get direct emission of white light. And it's a natural white light. It has a high color rendering index, so it's more like sunlight. The majority of white LED lights today are based on gallium nitride. They have relatively complex MOCVD structure. And the other problem is that they emit blue light that has to be converted to white by use of phosphors. So the benefits of our product are cost, because the ingoing materials are cheaper and the processes are cheaper. So we believe that in volume production, you can get up to a 10 times reduction in the cost of manufacturing with this technology. We have potential for higher light efficiency, because we directly generate white light, so we don't have to convert blue to white. The quality of the light is good. We've already demonstrated color rendering numbers over 90%, which means that we're very close to a natural sunlight in the coloring. And finally, because we can use plastic substrates, it's possible to make flexible lighting panels, which would be an ideal candidate for the flexible contacts we heard about earlier. If we look at the competitive landscape, as I said earlier, today the majority of lights that aren't light bulbs are based on compact fluorescent lights or fluorescent tubes. They contain mercury and have a light quality that is rather cold, not particularly desirable to have at home. Current LEDs, they're too expensive. They also don't have a really good light quality yet. There's other new technologies. There's zinc oxide thin film technology. There's a lot of difficulty with that in making PN junctions. Our patented technology goes around that problem by the use of polymers. There's a company called Glow in Sweden that's been successful with gallium nitride nanowires. That's the combination of the existing gallium nitride and nanostructures that we're using. And then there's OLEDs, organic LEDs. They're limited in intensity and power, and have not really had any breakthrough in white lighting, although I think they're growing in their application for displays. So our marketing strategy, our first product will focus on LED chips, and we'll focus on the areas where we have a unique advantage, and that is the quality of light and also the cost of manufacturing. Look at the milestones. The work that led to this product is based on research that has been going on in Chalmers University in Gothenburg and in Linköping University for the last 7 years. So there's been about $10 million invested in basic research and around $500,000 invested in Ecospark so far. This phase we consider is essentially complete. We have a proof of concept, and we've shown that we can make these devices on plastic and glass substrates, and we've taken out IP protection. The phase we're currently in, which we think will last for 15 months, is to take a lab chip design and make a industrialized chip design, which we can use for sampling of customers and iteration of the design. Following that, we plan small-scale production in the second 15-month period. We have a fab that we're using now in Norrköping, and this has enough capacity for our small-scale production. And then we anticipate getting our initial sales during this period. And then finally, we go to large-scale production, expansion, and significant revenue. By this time, we anticipate that we'd use a contract manufacturing partner for doing the manufacturing processing. So for these 3 phases that we have planned, we're looking for $6 million in funding. The team, the founder and inventor of this technology is Professor Magnus Wilander. He's a well-known expert in this field of zinc oxide and lighting. Myself, I have a background in opto industry and semiconductors. Our chairman, Hans Lindberg, he's had a successful exit with a company he started himself 20 years ago. And we have an engineering team of highly qualified experts, and another founder, Victor Kuzmin, who has a lot of experience in early-stage companies. So to summarize, we have a unique product that solves our customers' problems, and those are cost and quality of light. The market is enormous. It's a very hot market, and it's very fast-growing. The management team is experienced. The 2 of us have had a track record with startups with successful exits, and we have a strong IP platform. And we have a legal agreement with the research team to continue to feed us with new technology. So our offer to you is to invest in a better world and at the same time get a good return on your investment. Thank you.
Thank you for shining so much bright light on Ecospark. Time for 2 short questions, and then I think I need to make an announcement on the last company and how we will proceed here in order to keep some time.
Lighting is a fantastically large market with huge opportunities for carbon reduction, so it's a great market to be in. the challenge for LEDs has been the cost.
Yes.
What is your roadmap for driving the cost down, and how quickly can you do that? And how much does this chip impact the total cost of that LED bulb? You mentioned it's the most expensive component.
Yeah, it's over 50%.
It's over 50%?
Yeah,
okay,
typically.
so you can really enable the cost reduction process to happen. Can you give us an idea how quickly that can happen in your time frame?
So one advantage is from day one we have a cost advantage because the materials that we use, glass or plastic substrates and zinc oxide, are relatively cheap, whereas gallium nitride uses sapphire or silicon carbide substrates and then MOCVD growth that's relatively expensive. So we have an advantage in the materials and the processes that bring the cost down. So we're not only relying on volume. You can never win playing the volume game. But obviously, to make this be 10 times cheaper than the present technology, you also need the volume eventually.
How much time would it take to do that?
The volume, we anticipate 2 to 3 years we need to get there. So the second block in my second block of 15 months was to build up volume.
For that, let's say, total lighting solutions, do you need to change any peripherals or let's say, or surrounding instrumentation?
The first product, we'll make an LED that would be really a drop-in for the existing gallium nitride, so you could go in the same type of fittings that you can buy today. But because we can make these flexible panels, I think you can start thinking a little bit more out of the box and thinking what could you make that took advantage of those unique attributes. But the development and the engineering involved in doing that obviously is significant.